So let's talk about diffraction. Diffraction is a really simple concept, but it's majorly confused by a lot of people. So let's try to get it right, all right? Real simple. A wave is a disturbance in a medium. That's what it is, okay? It disturbs the medium. So let's say that you've got a wave and there's some sort of boundary that it's trying to get around. Like you could imagine sound going through like a doorway, or you could imagine a wave going through and there's a jetty. All right, so what happens after it goes past this boundary? Well, it's going to spread out to fill the medium because it's a disturbance in the medium. So once the boundary's not there anymore, well, geez, it's going to spread out to fill the medium. That's called diffraction. So here's a wave coming in, and then we've got a boundary. It's got to go through here. So it kind of chops off the wave here, but then after the wave passes through the boundary, it starts to spread out and fill in that part of the medium. All right? So that's diffraction. Okay, now, it's important to understand that the amount of diffraction that you'll see is of order the wavelength. So if you've got a really small wavelength, then you won't be able to observe the effects of diffraction. The best example of this is light. And this was actually used for centuries to argue that light is not a wave because it doesn't display diffraction. And you can see that very easily just by looking at shadows, right? You've got light coming down where there's a boundary, oop, suddenly it's dark, right? Now, of course, light really does display diffraction, but the wavelength of light is so small that you have to look very carefully to see it. You can, but you got to look really carefully. All right, another example of something with a small wavelength is high-pitched sound. You may not have noticed this, but you may have. High-pitched sound is easier to channel than low-pitched sound. If you've got a really low bass, then it kind of causes everything to vibrate. You can't really channel it. But if you've got a very high-pitched note, you can channel it out. Now, of course, if somebody's singing, then that's going to go out in all directions anyway. She's not trying to channel it. But if it's sung through kind of like a tube, then it will be channeled a lot more than large wavelength, low-pitched sound. Now, you've probably noticed this. If you're in a concert hall and you hear like the real low pitches, it really makes the whole concert hall vibrate. It's not at all directed at anything. So low-pitched sound has major diffraction. Ocean waves also show major diffraction. And in fact, jetties are used to channel ocean waves in a specific way using their diffractive properties. And that's diffraction.